Welcome back to the series of sessions on advanced concrete technology. We were discussing Module 2 fresh concrete. In this session, we will be discussing chemical admixtures. Admixtures are used to modify the properties of ordinary concrete so as to make it more suitable for any situation. It enables certain desirable characteristics to concrete as well as improves the strength and economic characteristics of concrete. Low strength concrete generally does not require the addition of admixtures to improve its characteristics. In general, admixtures can be classified into chemical admixtures and mineral admixtures. In this session, we shall discuss chemical admixtures. There are many different types of chemical admixtures available in the market. Among them, some of the admixtures are discussed here. First of all, let us consider plasticizers. They are commonly known as water reducers. These plasticizers can be added to concrete in two different ways. First of all, let us consider a concrete mix which is having a low workability. In that case, we can add required quantities of plasticizers to improve its workability without increasing or changing the water-cement ratio. In the next case, we shall consider a concrete mix which is having a suitable workability. In that case, we can reduce the water-cement ratio and add required quantities of plasticizers to maintain the workability that is required. So what happens is we are able to reduce the water-cement ratio by the addition of plasticizers. As a result, that particular mix will be expecting a higher strength after hydration. The usual range of plasticizers will be from 0.1 to 0.4%, and as a result of the addition of plasticizers, we are expecting a water reduction of say 5 to 15%. We can also think about having an increase in slump from 30 mm to 150 mm when we are adding plasticizers without changing the water-cement ratio. Now let us discuss the action of plasticizers. Plasticizers reduce the surface tension of water, and as a result, water can be easily dispersed inside the concrete. Also, as shown in the figure, these chemical plasticizers get attached to the cement particles. Plasticizers being negatively charged, when they get attached to the cement particles, it causes the cement particles to repel each other. So, plasticizers lubricate the cement particles, and as a result a steric hindrance will be created and it causes repulsion between the cement particles. The positive influence is that the cement particles get dispersed inside the concrete mix and it ensures proper hydration of concrete. It is also observed that there is change in the morphology of the hydration products due to the addition of plasticizers. It has to be taken care that when plasticizers are added more in volume, there are possibilities of more retardation in concrete. So, it is always very important to consider that only optimum quantities of plasticizers are to be added as per the recommendation of the manufacturing company. Otherwise, plasticizers will negatively influence the characteristics of concrete. Now let us discuss super plasticizers. They are similar to plasticizers but with better capacities. That is, super plasticizers can reduce the water content up to 30%, whereas plasticizers will be reducing water only up to 15%. The use of super plasticizers are preferred for flowing, self-leveling, self-compacting type of concrete, which is adopted for high strength and high performance concrete. Considering the action of super plasticizers, they are similar to that of the plasticizers. That is, at the same water content, we can have a more workable concrete by the addition of plasticizers. Similarly, at the same workability, we can have a reduced water-cement ratio by the addition of super plasticizers. Also, when we are reducing the water-cement ratio, there will be an increased strength obtained by the concrete. But it has to be taken care that the super plasticizers will be effective only if the initial slump is in the range of 20 to 30 mm. Also, as discussed in the previous case, overdosage of superplasticizers may negatively influence the characteristics of concrete, such as it may cause retardation of concrete as well as excessive air entrainment. We have discussed plasticizers and superplasticizers, and now we shall discuss retarders and retarding plasticizers. A retarder is an admixture that slows down the chemical process of hydration. Gypsum can be a retarder. As we have discussed during the manufacturing of cement, gypsum is added in order to increase the setting time of cement. Also, sugar can be a retarder of concrete. Now let us discuss the need for retarders. Retarders can be adopted in the following circumstances. Let us consider a situation that the atmospheric temperature is much higher than the optimum temperature of say 27 degrees Celsius. In that case, hydration of concrete will be happening at a faster rate. In order to reduce that hydration, we may add retarders. Similarly, when the concrete is to be placed in difficult conditions, we should delay the setting of concrete so that concrete is properly entered into the volume in which we are placing the concrete. Also, when we are using ready-mixed concrete, concrete is to be transported from the place of mixing to the place of concreting. During the transit, we have to ensure that no setting of concrete is taking place. In that case, retarders can help to prevent the premature setting of concrete, that is, the setting of concrete can be prevented before it is placed at the required location. Retarding plasticizers are retarders mixed with plasticizers or superplasticizers. It should be taken care that the retarders added with the plasticizers may settle down, and hence we have to shake well before it is used. Otherwise, these ingredients may cause excessive retardation and failure of concrete structures. Accelerators are chemical admixtures that are having the property just opposite to that of retarders. That is, accelerators increase the rate of early strength development. It is having following advantages. If we want to remove the formwork of concrete or reduce the curing period of concrete, we can think about adding accelerators to concrete. Also, since the strength is gained at a faster rate by the addition of accelerators, we can make use of the structure at the earlier period of time itself, as well as we can move on to the next level of construction. Also, in the areas of cold weather, due to the low temperature around the concrete, there is a chance that the setting happens at a slow rate. In that case, accelerators can increase the strength gain speed. Also, when we are thinking about doing emergency repair works, accelerators can help in gaining strength at a faster rate. Calcium chloride is one of the commonly used accelerators, but it is not generally preferred for RCC structures. The presence of chlorine causes corrosion in reinforcement bars. In place of calcium chloride, we can use chlorosilicates or triethanolamine as the accelerators, but they are comparatively expensive. In the market nowadays, very powerful accelerators are available which can even make the concrete set within 5 minutes or so. Such accelerators are preferred in underwater concreting and the concreting of waterfront structures. Accelerating plasticizers are obtained by mixing accelerators and plasticizers or superplasticizers. It will be ensuring faster setting of concrete. Some of the accelerating plasticizers or superplasticizers are triethanolamine chlorides, calcium nitrite, nitrates and fluorosilicates. Air entraining admixtures are one of the important type of chemical admixtures. These admixtures are added to incorporate or entrain small air bubbles inside the concrete to modify the properties of plastic concrete, such as it modifies workability, segregation, bleeding, and finishing quality of concrete. It also modifies the properties of hardened concrete. In India, air entraining admixtures are not generally used because frost scaling of concrete is not a serious problem in our country. There are different types of air entraining agents or admixtures available, such as natural wood resins, animal and vegetable fat and oils, various wetting agents such as alkali salts, water-soluble soaps of resin acids, etc. You can see in the picture that when air entraining admixtures are added, they get attached to the small air bubbles. These air entraining agents being negatively charged, when they get attached to air bubbles, they cause the dispersion of air bubbles to the volume of concrete. That will ensure better workability of concrete as well as better hydration of cement. Factors influencing the amount of air entrainment are water-cement ratio, type of the grading of aggregates, mixing time, the temperature of the atmosphere around, then the type of cement and the influence of compaction, also the admixtures other than air entraining agents added to concrete. As you can see in the picture, the air entraining agents get attached to the small air bubbles and causes the air bubbles to repel each other. Since these air entraining agents are having negative charges, when they get attached to the air bubbles, these air bubbles start repelling each other and they get distributed inside the concrete mix. As a result, following effects are observed in concrete. It increases the workability of concrete. Also, there will be less tendencies of segregation and bleeding. It also reduces the permeability and increases the resistance to chemical attack. Also increases the resistance to freezing and thawing effect. It permits the reduction in sand content as well as improves the placeability and early finishing. It permits reduction in water content. These are the positive influences of using air entraining agents. But there are some negative influences also. Due to the entrainment of small air bubbles, there will be reduction in unit weight and which in turn causes reduction in modulus of elasticity as well as reduction in strength. We were discussing entrained air due to the addition of air entraining admixtures. Also, while discussing the procedure of concreting, we have discussed entrapped air. That is, during the placing of concrete, the air gets entrapped. So, entrained air and entrapped air are two different things and they have different influences on the concrete. Entrained air is intentionally incorporated into concrete and it will be having smaller diameters of the order 5 microns to 80 microns. It will be positively influencing the properties of concrete such as workability and many other properties. Whereas entrapped air comes inside concrete when concrete is placed into the formwork. The diameter of air entrapped is of the order of 10 to 1000 microns. It is not having a positive influence on concrete, hence it has to be removed by proper compaction.